You are holding something in your hand right now, whether it's your phone, a cup, or the arm of your chair. You trust your fingers, and they have earned that trust by keeping you alive your entire life. But in 1898, in a small laboratory near the Sorbonne in Paris, I discovered an element so lethal that my notebooks are still sealed in lead-lined boxes at the Bibliothèque Nationale de France. More than a century later, researchers who wish to read them must sign a liability waiver before they are allowed to touch them, and the pages will remain dangerous for another 1,500 years. The night I first saw that element, I thought it was beautiful, a faint blue glow in the darkness, and I called to my husband to come and look. We stood there together, marveling at something that was destroying us the entire time, and neither of us felt a thing. That is the subject I want to discuss with you. Not merely radiation, though we will speak of that, but the deeper truth it reveals about the universe you inhabit. The forces that shape the earth, that govern your cells, that could end civilizations, are almost without exception the ones your body was never built to detect. The most dangerous forces in the known universe operate in perfect silence, and your magnificent nervous system has no answer for them at all. Let that settle for a moment before we go further. Let me take you back to where this understanding began, not with theory, but with a simple observation that should not have been possible. In 1896, Henri Becquerel placed uranium salts on a photographic plate wrapped in thick black paper, and the plate was sealed so that no light could reach it and no chemical could touch it. When he developed that plate, there was an image, because something from the uranium had passed through the paper, through the darkness, through every barrier, and impressed itself upon the emulsion as clearly as light through an open lens. Picture placing your closed laptop on a sealed box, and when you open that box a week later, finding a perfect image of the laptop burned into the lining, with no light, no heat, and no contact involved at all. That is what Becquerel found. He called these uranic rays, and did not quite know what to make of them, and neither did most of the scientific community. The discovery that had just earned Röntgen the very first Nobel Prize in physics, his X-rays, required a cathode tube, electrical current, and deliberate apparatus to produce. Becquerel's uranium simply radiated, spontaneously and continuously, without any external source of energy that anyone could identify, and most physicists treated it as an oddity, a footnote. I did not see a footnote. What I saw was a question that no one was asking properly, and it consumed me, not because it was fashionable, because it was decidedly not fashionable, but because the source of that energy was a mystery that demanded an answer. My doctoral committee at the Sorbonne initially wondered whether there was enough substance in Becquerel rays to sustain a thesis, and I was, after all, only the first woman attempting a doctorate in physics in France. But I have always believed that the questions others pass over too quickly are precisely the ones worth pursuing, because the seemingly small anomaly, the measurement that does not quite fit, those are the doors to entirely new room. I began with careful, systematic measurement, because that is always where one must begin, not with speculation, not with grand theories, but with the patient and precise act of measuring what is actually there. The device I used was one my husband Pierre had developed with his brother Jacques, a piezoelectric quartz electrometer so sensitive it could detect currents no other apparatus of the time could register. What I was measuring specifically was the ability of uranium compounds to ionize the surrounding air, to strip electrons from air molecules and turn an insulator into a conductor, all of it invisible, silent, and continuous. And what I found changed everything, because the intensity of this radiation depended only on the quantity of uranium present. It did not depend on its chemical form, or on whether it was combined with other elements, or on temperature, or on light, or on any external condition at all. The radiation was an atomic property, and it came from the atom itself. The reason that mattered so enormously, and the reason it was nearly heretical in 1898, is that every scientist alive at that time considered the atom to be indivisible, inert, and unchanging, which was the very meaning of the word atomos, uncuttable. I was claiming on the basis of painstaking measurement that atoms themselves were active, that they were emitting energy from their own interior. The name I gave this phenomenon, radioactivity, was my way of saying that this activity belongs to the atom. And if atoms are active, then they are not the simple indestructible spheres everyone assumed, because something is happening inside them. But the measurements told me something else as well, something that cost me weeks of sleep. When I tested pitch blende, the crude ore from which uranium is extracted, it turned out to be more radioactive than pure uranium itself, and by a wide margin. On the face of it, that was impossible, because if radioactivity depended only on the amount of uranium present, then the pure element should have been the most active sample, and the ore, which is mostly other material, should have been less active, not more. Only one explanation made sense. The pitch blende contained something else, some unknown element present in tiny quantities that was far more intensely radioactive than uranium. Pierre set aside his own brilliant studies of crystal symmetry and magnetism at that point, because he recognized what I had found, and together we began the labor of separation. I must be honest with you about what this entailed, because it was not glamorous in any way. We worked in a converted shed at the School of Physics on the Rue Lomont, a space that had previously served as a dissecting room for the medical faculty, and it leaked when it rained, turned stifling in summer, and freezing in winter. A visiting German chemist once described it as a cross between a stable and a potato cellar. In that shed, I processed tons of pitch blende residue by hand, dissolving, boiling, filtering, precipitating, and dissolving again. For every 1,000 kilograms of ore I reduced, I recovered perhaps a few milligrams of material worth testing further, and most days ended with nothing at all. The work was not merely tedious, it was a confrontation with probability itself, but the electrometer guided every step. At each stage, I measured which fraction carried the radioactivity, and pursued that fraction further, because the instrument served as my eyes in a domain where I had no other way to perceive what I was chasing. We found not one but two new elements. The first I named polonium, for my homeland, and the second was radium, element 88 on the periodic table, with an atomic weight I measured at 225. Isolating enough radium chloride to make that determination required 4 years of labor, reducing 1,000 kilograms of ore to 1/10 of a gram. And when the work was done, the substance sat in its small glass vessel and glowed. I need to tell you about that glow. Pierre and I would sometimes go to the shed at night after our daughter Irene was asleep, and we would not light a lamp. We would simply stand in the darkness and look at our samples, the little glass tubes and capsules arranged on tables and shelves, shining with a faint bluish phosphorescent light. I would say to Pierre, "Look, look," because those glimmering luminous silhouettes really did resemble faint fairy lights. But here is what you need to understand. That beautiful glow was the visible signature of atoms tearing themselves apart, and radium nuclei were disintegrating, ejecting what Ernest Rutherford would classify as alpha and beta particles along with gamma rays, all at tremendous velocities, releasing energy that had been locked inside matter since the formation of the Earth. 1 gram of radium undergoes 37 billion disintegrations every second, and each disintegration breaks bonds held by what physicists now call the strong nuclear force, the most powerful force in nature, millions of times stronger than any chemical bond. The light we admired was just the tiny fraction of that energy our eyes could perceive, while the rest, the alpha particles, the beta particles, and the penetrating gamma radiation, passed through our bodies without the slightest sensation. We stood in the presence of a force powerful enough to shatter atomic nuclei, energetic enough to penetrate flesh and bone, and our bodies registered nothing beyond a faint visual charm. We carried those tubes in our pockets, and I kept samples in my desk drawer. Pierre once deliberately strapped a vial of radium to his arm for 10 hours to study its effect on skin, and the result was a burn, a red lesion that took weeks to heal. Yet during those 10 hours he felt nothing at all. The damage was done in perfect silence. This is the pattern I need you to see, because it extends far beyond my laboratory. Your fingertips can detect a surface feature 13 nanometers high, smaller than a virus, and your ear can register vibrations so faint they move your eardrum less than the diameter of a hydrogen atom. Your eye can respond to a single photon of light. These are instruments of astonishing precision, and evolution spent hundreds of millions of years perfecting them. But ionizing radiation walks past every one of them as though they do not exist. The reason you cannot feel it is that there is no receptor in your body designed to detect it. Evolution never built one because, in the natural environment, the levels of radiation organisms encountered were too low and too gradual to make such a sense worth developing. The damage instead accumulates slowly, cell by cell, and mutation by mutation. And when an alpha particle passes through living tissue, it shatters DNA, ruptures cell membranes, and creates cascades of reactive molecules that continue causing harm long after the particle has stopped. A single alpha particle can damage tens of thousands of molecules along its path, and by the time the consequences appear as a disrupted blood count, as fatigue, as leukemia or cancer, the cause may sit weeks, months, or years in the past. The connection between exposure and consequence stretches across time in a way that is completely invisible to intuition. And what I find extraordinary in the way that deep truths can be extraordinary even when they are terrible, is that this same pattern of extreme danger paired with zero sensation extends well beyond radiation. Sound waves below 20 hertz can damage organs and induce panic, yet your ears register nothing, just pure silence at frequencies that are rearranging your insides. Carbon monoxide binds to your hemoglobin more eagerly than oxygen, yet you cannot smell it, taste it, or see it, and it kills by quiet displacement. The universe's most destructive agents all share one signature, and that signature is silence. When I stood before the Royal Swedish Academy for the second time, now to receive the Nobel Prize in Chemistry, I made a point, I believe, ranks among the most important in all of physics. Radioactivity represents the spontaneous transformation of elements, and what we were observing was nothing less than transmutation, the very thing alchemists had dreamed of for centuries, happening naturally and continuously inside matter itself. Atoms of one element were becoming atoms of another and releasing energy in the process, and none of it responded to anything we did. You could heat the radium, cool it, dissolve it, or combine it, and the radioactivity continued unchanged, governed by laws that operated beneath the level of chemistry, beneath anything we could influence with our hands and instruments. This is what I mean when I say the most dangerous forces cannot be felt, and I mean something very specific by it. The forces that operate at the deepest level of physical reality, at the level of the atomic nucleus, are precisely those that evolved biological systems are blind to, and they are the most energetically concentrated forces in the known universe. A few years after our measurements, Einstein published the equation that explained why, because mass itself is concentrated energy, E equals mc squared, and the energy locked inside 1 gram of matter is staggering in scale. Pierre and I calculated that 1 gram of radium releases enough heat in 1 hour to melt its own weight in ice, and it does so continuously, hour after hour and year after year. In its full decay, 1 gram of radium releases as much energy as burning 400 kilograms of coal, all from a single gram, and the entire time, if you held that gram in your hand, you would feel only a slight warmth, barely noticeable and almost pleasant. This asymmetry between perception and danger is not a flaw in human design, but a statement about the architecture of the universe. The forces that are most destructive operate at scales, both tiny and vast, where sensation simply does not reach. Ultraviolet light damages your cells before your skin can register pain, and by the time you feel the sunburn, the harm is already done. Electromagnetic radiation, from the hardest gamma rays to the gentlest radio waves, passes through your body continuously, while your awareness of it sits at 0. Today you might carry a Geiger counter, an instrument that clicks when radiation is present, making the invisible audible. But in my time, the only instrument sensitive enough was the electrometer, and the only way to interpret its readings was patience. We live, all of us, inside a storm of invisible forces. Every moment you are bombarded by cosmic rays, particles from distant supernovae that have traveled across the galaxy and now pass through your body at nearly the speed of light. Radon gas seeps from the ground beneath your buildings and decays in your lungs, while potassium 40 inches your own bones emits radiation from within you. You are radioactive, though faintly, and the earth itself is kept warm in part by the radioactive decay of uranium, thorium, and potassium in its interior, a vast, slow furnace that you walk upon without the slightest sensation of heat from below. I want to tell you something about what this understanding does, not to physics, but to how you move through the world. When you truly grasp that your senses show you only a narrow and biased portrait of reality, something shifts inside you. You stop trusting appearance as a measure of danger or safety, and you begin to understand why careful measurement matters, not as a pedantic exercise, but as survival. Everything I accomplished in my work came from measuring what could not be felt, because the electrometer was my true sense organ, perceiving what my body could not. Every advance, every discovery, every new element, all of it came from trusting instruments over intuition, from following the numbers into territory where human sensation simply goes dark. Today, instruments at the LIGO Observatory detect gravitational waves, ripples in space-time from collisions a billion light-years away, oscillations so faint they compress a 4-kilometer detector arm by less than 1,000th the width of a proton. That is measurement as perception. That is extending consciousness into the silence. And this is the great lesson of my life's work, one I do not think is confined to physics. The things most likely to change your world, for good or for destruction, are rarely the things that announce themselves with noise and spectacle. The gradual accumulation of small, imperceptible effects is how radiation damages tissue, how elements transmute, and how the earth itself was shaped over billions of years, because the patient invisible forces are always more powerful than the dramatic visible ones. The people who fear radiation most are often the ones who understand it least, and fear without measurement is superstition, while understanding, even of something terrifying, is freedom. I spent decades in that laboratory, surrounded by substances that were steadily and quietly breaking down my blood and my bone. I breathed dust laden with polonium and radium, and I developed techniques for concentrating radioactive material with my bare hands. The aplastic anemia that would eventually stop my heart had been building inside me for years, and I felt nothing, no alarm, no pain, no warning at all. The work felt like what it was, a joy, an honor, and the deepest purpose I had known. My daughter Irene continued the work after me. She and her husband Frederick discovered artificial radioactivity, the ability to make stable elements radioactive through bombardment, and she won her own Nobel Prize for it. And she too died of the same invisible forces, the same silent accumulation, the same leukemia born of years in a laboratory full of things that could not be felt. The forces did not care about her brilliance any more than they had cared about mine, because they followed their own laws. That is what the invisible forces teach us, if we are willing to learn. Not that the world is more dangerous than we thought, though it is, but that our knowledge must reach deeper than our senses. The truth about nature does not wait for us to feel it. It acts continuously, whether we measure it or not. In life there is nothing to be feared. There is only something to be understood, and when we extend that understanding far enough into the places where our senses fail and our intuition misleads, into the silence between atoms where the strongest forces in the universe do their work, we find that the universe is even more extraordinary than it appeared. Not less dangerous, not more comforting, but more extraordinary, and that I have always believed is enough.